Hello and welcome everybody to the module 2, which will take a look at the field of energy. My name is Daniel Hojski. I'm coming from University of Maribor. So today we will take a look how a life cycle approach can transform energy planning with a focus on the public transport sector. As we know, transport sector accounts for around 1/5 of EU emissions, according to Eurostat. And unlike energy sourcing, its emissions are still rising. Transport sector relies on resource-intensive supply chains, and this reveals a deeper challenge. As our economy remains largely linear, this means take, use, and dispose, driving resource depletion and ecosystem damage. The International Council on Clean Transportation made a predictions for 2050 in terms of transport emissions. The three scenarios covered the baseline 2024, which includes policies adopted up to August of 2024, and also two more ambitious scenarios, the momentum and ambitions, which scenario which aligns with the Paris Agreement's climate goals. We can see on the graph, which is representing those scenarios, that in all three scenarios the emissions will in the next years will still be rising, and hopefully then if we adopt actions and policies, the trend of emissions can start declining. How much it depends on the actions taken. But to achieve more ambitious goals, existing policies and practices will need to be further enhanced. And when talking about enhancing, the circular approach is a novelty or unstandardized or unused practice in the transport sector. Unlike a linear economy which treats resources as disposable, circular principles keeps resources in use, minimizes waste, and generates natural systems. Within CE4CE project, there's been a AETA approach developed, which enhanced steps towards circularity in public transport. This letters stands for 4 stages, and the stages are: avoid unnecessary energy demand, extend resource life and efficiency, transform energy systems toward renewables, and enable innovation, governance, and collaboration. The sustainable development, which is over the past years or decades, has been taking actions at. There's been taking actions, but those actions, or most intention on those actions, were on the vehicles. As electric vehicles rapidly emerge, energy consumption is increasing accordingly. And with the increase, there is also increase of need of development in addition in other fields of energy use. Fleet electrification plays an important role as it helps to reduce emissions and reliance on fossil fuels. But in terms of energy in public transport, we also need to consider a wider picture. speaking also the energy infrastructure and energy management. And as said, circular economy principles are about maximizing usage and minimizing costs and impact. And this goes in line with life cycle approach or life cycle assessment, which is a method for evaluating the environmental impacts associated with all stages of product, system, or service over its entire life cycle, from raw material extraction, manufacturing and assembly, distribution and operation, maintenance and use, and end-of-life management. In public transport, energy stages can be divided into embedded energy, operational energy, and end-of-life impacts. Public in public transport energy use sector, traditionally the actions or the focus has been assessed mainly to operational stage, namely tank to wheel. But SCI expands this view also by considering the usage stage, namely well to tank, which consider how energy is produced, processed, and supplied before it reaches the vehicles, and also end of life stage impact. So long-term environment impact, recycling or repurposing components. In public transport energy field, the main component are the batteries. So the actions, prepared actions, were divided into the AETE approach, the first stage, avoid stage, or the upfront stage, refers to clean energy source. As said, electrification and in general modern fleet is the essential first step in decarbonizing public transport. So here the actions like green procurement and reducing dependence on fossil fuels are of big importance, as we see the predictions that up until 2030, half of vehicles will be electric, and only and the 15% will be on fossil fuels, and even those will be of low or lower emission standards. In line with reducing the use of non-clean energy, integrating renewable energy sources, RES, and recovering waste energy, V2E, also lowers the environmental impact and enhances system resilience, but also can be also economically beneficial. When we talk about renewable energy sources, most common are solar, wind, water energy, and when by recuperating energy, there is otherwise wasted energy from breaking trains comes to mind. Different areas, sectors can then be gathered or joined in the shared spots like mobility hubs, where different modalities come together and also can share the energy. So this is also maybe more further action, but also important when thinking about using the energy from, let's say, outside sources. So the second stage is the extend stage or operational. It covers actions of charging and storaging, let's say infrastructure. Infrastructure investments are also important as charging systems must keep with fleet growth to ensure efficiency and reliability. So infrastructure must be reliable. It depends on the route type, existing charging infrastructure, and vehicle types. And the step forward is the potential of energy storage, which then enable the storage and later use of energy. The principle of charging and operational use is also influenced by energy efficiency and monitoring, like charging strategies, eco-driving bus, rapid transit, predictive maintenance, simulations, or operational processes and scenarios. Combining all three possibilities on energy efficient use emerges: offloading and supporting the grid, the network, use of cheaper night tariff energy, and use of renewable energy sources. This is also important as the trend in the previous years, the trend shown that the energy cost of energy can increase rapidly, and also the need for the amount of energy is also increasing. Then the third stage is the transform stage, end of life. The focus shifts to managing batteries and other components after they reach the end of their operational life. So actions like reuse and repurposing, second life application in stationary storage, depot buffers, or renewable energy systems can help to extend lifespan and delay recycling. Then recycling recover critical materials and also design for circularity, which then helps to the processes of recycling, and digital product passports, which track composition, usage, and conditions, which also give the recycling processes its affirmation. And the last stage is the enable stage, which covers EU regulatory framework. The core drivers are the European Green Deal and Circular Economy Action Plan. For the energy focus, the binding obligations for energy systems and batteries are the battery regulation and batteries directive, which contains mandatory recycling quotas, support for second life applications of batteries, and digital product passports tracking composition, use, and state of health. These actions will step into force in the next years. There is also Waste Framework Directive, which apply waste hierarchy, proper handling of energy-related waste, and extended producer responsibility. And here is a visual graph or scheme that represent those principles, 7R principles for circular public transport systems that was developed in project CE4CE, and those actions that are relevant for the energy use are again shown in the slide. And to sum it up, so what can SCA approach contribute to public transport operators? By applying this assessment approach, PTOs can better approach the goal of low emission and efficient public transport. It can help to identify hotspots, energy consumption and emission across the full system, optimize energy management strategies for both operational and embodied energy, make informed decisions on vehicle technologies, energy sources, and infrastructure design, and support circular economy practices as been described in this presentation. So thank you. This is all from my side. Goodbye.